out, I'll work her. So whenever you're ready to. All right. Let's look at vlsm. And first, let's glance at one other thing in the chapter. There's a good review for y'all in the beginning of the chapter. I wish they had done it in the other book, but I did it for y'all anyway. But they didn't give you some of this information where they talked about the classes, the ABC classes, and also the bits on it, where I taught y'all which bit was it, defined it by the class. So do look back at that about how that's doing it. It is IP version 4. We are in IP version 6 now. So be aware of that. That IP version 6 is coming on rapidly. As of last week, the end of April 2010, that the people that issue the IP addresses on IP version 6, the head of it says we will be out of addresses in 1.5 years. So we're going to have to move to IP version 6 soon, but we're talking version 4 today. Now, let's look at vlsm. And consider vlsm on, it's a solution to the whole problem, which is variable length subnet masking. It became popular in the late 90s with the original running out of IP addresses. vlsm, along with NAT, became ways to get by on where we didn't run out of IP addresses back then. Now we're running out again, really running out this time, with no backup. But vlsm will allow you to take a subnet that you need to subnet and not be limited to just the same length size subnets. Because when we did subnetting before, all you did was that you decided what's the maximum number of hosts you needed per subnet, or what the maximum number of subnets you needed. All of the subnets you created had the same number of hosts on. And if y'all remember back from those calculations, depending on what we did, we ended up with a large wastage doing it, but we did manage to break it down into subnets and make it a little bit better set up. So management-wise, it was better, but we wasted a lot of addresses. vlsm is going to allow us to cut that waste way down. Basically, what you're doing, to put it into a real short term, is you're subnetting the subnets. So let's go in and take a Class B address. So let's just use 172.16.0.0. Or let's change that one slightly. That would be a big one, but. So we got 172.16.1.0 as our network address. I don't really like that one either. I want the other one. .0. So we got a full level Class B address. What we want to do is, obviously if you use that address and went just straight off of it, we could go out there and put a whole bunch of addresses in there that we've got both the last 2 octets available to us to put host addresses into. And that you've got a large number of hosts. But if we wanted to subnet it, we're going to start losing. But here's the thing. If we wanted to subnet this and we had some variable size subnets that we're going to create, which is going to be the real problem in the real world. But it's going to end up costing us because of one's lost not being able to do it. But let's assume that our first subnet, we want 400 hosts on. And then we want 2 subnets with 100 hosts. And then we want 3 subnets with 2 hosts each. Now, why would we need a subnet that's only got 2 hosts on it? What are those subnets? Anybody got an idea? Where have y'all put a subnet that's only got 2 hosts on it? If you're doing a router-to-router connection on that serial port, how many hosts can you have on that subnet that goes between the 2 routers? 2 hosts. So in this case, we may have, it may be a case of we've got 3 routers in our network, okay, or something. But we've got a need for, and those subnets will only have 2 hosts. So that's all you need there for. There's no reason to make a bigger subnet for them. Because when it's a router-to-router connection, the only thing you can have on that connection is a router at one end and a router at the other end. And nothing else can be put in there, so that subnet can only have ever at most 2 actual hosts on it. So when you did subnetting before, if you ended up with all of them that had 126 addresses on each subnet, you ended up wasting 124 addresses for each of your serial connections, because you had to use a whole subnet that had 126 usable addresses, and 2 of them was all you used, so you had 124 wasted addresses. This way, we're not going to waste. Now, what we're going to want to do this is, we're going to first subnet for the largest number, or if there are several of them that are in the same range, and the secret is look at your column values from your binary and see how many bits are you going to need to borrow. So if you had anything that was above the 256 needing, actually 254, of number of hosts up to 510, then you need to do them all in one set group. Look at the ranges of your binary columns. Y'all follow on that? Because that's how many bits we're going to borrow. So in this case, we've got 2 columns to borrow from, 2 octets. So we've got with 8 positions in each, and hopefully I can 2, 3, 4, 5, 6, 7, 8. So we've got 2 octets to use. 16 bits. We need for 400 hosts. Okay? How many bits are we going to need to borrow to set up a subnet that contains 400 hosts? Remember, we're going to number from the left in this case and count down. So the 1 to 2, 4, 8, 16, 32, 64, 128, 256, 5, 12. Okay? Oh, so we can get it in